2.
Operational modes. What can be the operational modes? Hmm?
Access and trunk.
Static and trunk.
Okay. Tell me when operational mode can be the trunk. Like if the operational mode is trunk, then what can be the administrative mode? Tell me the all possibility.
Desired state.
If administrative mode
DA,
is
sir, dynamic desirable and dynamic auto,
okay,
sir.
if the administrative mode is dynamic desirable, then operational mode can be trunk and
Either a dynamic auto, the remote side, and the switch side is dynamic desirable, sir. The switches will trunk and dynamic desirable, both side dynamic desirable will form a trunk, sir.
and the other scenario, that is fine. The one scenario is dynamic desirable. If the administrative mode is dynamic desirable, then operational mode will be trunk. What will be the other scenario? If the mode is static trunk, then also operational mode will be trunk only.
Yes.
Right. And guys, first before starting the VTP protocol, we need to cover two things. One, native VLAN, and second is inter-VLAN routing. Right. So you know the routing. What is the meaning of routing? Routing means process of forwarding data packet from one network to another
Other
network.
network.
Like when default gateway is required. That is called routing. Okay, so let me start with the native VLAN as you don't have any question. Is my screen visible?
No.
Native VLAN. Yes, so what is native VLAN? Who will explain?
Sir, you are not visible.
Yeah, I am sharing the screen. Who will explain the native VLAN?
So
What is
tagging
native
and tagging
VLAN?
not perform.
Tagging will not perform. Where?
Tag, on the trunk port.
On the
On
trunk,
switch port.
not switch port, on the trunk port.
Yes.
There are many types of switch port, right? So where tagging will perform only and only on trunk link, right? So it is used to send untagged traffic on the trunk link, right? And only one VLAN can be your native VLAN. Only one VLAN can be your native VLAN. For an example, switch 1 and switch 2, this link is trunk link, right? Here guys, I have lots of user in VLAN 100. Lots of user in VLAN 100 on both switches, on switch 1 and switch 2. Right, so we don't want to perform tagging for VLAN 100 only. For rest all VLAN still tagging is required. Right, so I will configure native VLAN 100 on both switch. Here native VLAN is 100 and on switch number 2 also native VLAN is 100. Now for the native VLAN, switch will not perform tagging. 100 is the native VLAN. Native VLAN. So for native VLAN, how communication will happen? Who will explain? How? Let's suppose for an example, this is the PC in VLAN 100 and here also I have PC in VLAN 100. PC in VLAN 100. How these two PCs are going to communicate without tagging on the trunk link? Here IP MAC address is A, here MAC address is B, here IP address is 10.1.1.1, here IP address is 10.1.1.2. Yes, tell me the process, complete process. This is port number 1, this is port number 2, this is port number 1, this is port number 2. Right, this link is the trunk link between switches. So when I will ping 10.1.1.2, this PC will generate ICMP, right? To send the ICMP request message, PC1 need what? MAC address of 10.2. It will look up their ARP table. If MAC address is available, then it will send. ICMP request message. If MAC address is not available in the ARP table, it will generate ARP request broadcast message. It will forward to switch 1, right? Let's say broadcast message source A, destination MAC, all F. So now switch 1 will check the receiving interface is a member of which VLAN. So receiving interface is member of which VLAN? VLAN 100. So switch is going to learn a MAC address in VLAN 100 first. VLAN 100 MAC address A and port number 1. Then it will forward this from the trunk link without any tagging. Without any tagging, it will not perform tag. The reason VLAN 100 is native VLAN. And when switch 2 will receive any traffic without tag on the trunk link, it will get to know, okay, this is the traffic of VLAN 100, right? So whenever switch will receive untagged traffic on the trunk link, that means this traffic belongs to native VLAN. Got it, guys? Is it clear?
Sir, switch 1 will forward on all the, all the ports as well as trunk port, right, sir? Or
All the ports in VLAN 100.
all the ports in VLAN 100 and as well as the trunk port.
Trunk port, right?
Okay.
And as VLAN 100 is native VLAN, it will not perform tagging. It will not add tag value, right? So what we can say, it is native VLAN is used to support untagged traffic on trunk link. See, this is very important for interview as well and for real-time network as well on the trunk link. One VLAN can be the native VLAN, right? Only one VLAN. And guys, yesterday also I told you that ISL does not support native VLAN, right? Only .1q support native VLAN. Support by .1q only. 1q only. Then anything else? By default, which
So
VLAN is native VLAN on switch?
1.
Yes. Any question?
Sir, the receiving switch, what it will do, it will the switch 2 when the
Switch 2.
frame is
When
received.
switch 2 will receive the traffic on the trunk link, it will see, okay, there is no tag. That means
Okay.
it's a traffic of native VLAN. Native VLAN is 100, so it will forward from this interface.
Okay. It will forward to all the interface on VLAN 100.
Correct. If this is a broadcast. If it is unicast,
Yeah,
then
okay.
from the particular interface.
Okay, sir.
Okay.
Okay, sir.
And
Sir,
by
native VLAN is per switch basis or per link basis?
per link basis on each trunk link.
So if I have multiple trunk links, so I can configure multiple native VLANs on every link.
On one switch you can configure only one trunk, one native VLAN. On one switch you can only configure one native VLAN. And by default, which VLAN is native VLAN?
1.
VLAN 1.
By default, VLAN 1 is
VLAN 1.
native VLAN.
VLAN 1 is the default VLAN.
Right.
Sir, in which kind of scenario we will use this, sir, native VLAN? Like,
I already told you now, when you want to perform untagged traffic, when you want to send untagged traffic on the trunk link. Like what
Sir,
is
why
the
would you
issue
want
with
to
the tagging? Switch is using CPU, right? So when we have lots of users, lots of devices in one VLAN, usually we are configuring that VLAN as a native VLAN, so that switch will not perform tagging.
okay.
Sir, I have studied somewhere that native VLAN is the VLAN that carries information about other VLANs also. Is this correct?
No. This is only just to support untagged traffic on the trunk link. Okay. And then command. Command is same switch port.
Sir, this native VLAN, which scenario we can use it, sir?
In any scenario you can
Or
use.
which situation?
In any
Sorry,
situation
sir.
you can use.
Situation means which
In
which
real time.
situation we can use, sir?
For my company,
Yeah.
let's say on these switches,
In real
there
time.
are some VLAN, VLAN 10, 20, 30. Three VLANs are there, right? 100 users are there in VLAN 10,
Okay.
200 users are there in VLAN 20, and 300 users are in VLAN 30. So what I don't want to perform
Okay.
tagging for VLAN 30 for 300 users. So I can configure VLAN 30 as native VLAN,
Okay.
right?
Okay.
Let's say in VLAN 10 you have lots of servers and you don't want to perform tagging for those servers, like whenever you will receive or
Okay.
forward traffic for the servers in the server room, right? So you can configure VLAN 10 as native VLAN,
Okay. Okay, sir. Thank you.
right,
But
where
how
we have
switch to
more
will know
users.
no,
Yeah.
how switch to will know I need to forward traffic to which computer, sir? Like which host
what i
if for
told you
VLAN.
what I told you that switches, if switch is forwarding traffic on the trunk link, it will add the tag value, right? And this way, when receiver switch will receive the traffic, it will check tag and then it will
Correct.
identify the
If
VLAN. For the
yeah,
native
what about
VLAN, switch is not going to perform tagging. Means whenever switch will receive traffic without tag on the trunk link, then it will get to know that this traffic belongs to native VLAN. If switch is receiving a traffic on the trunk link without tag, that means this traffic belongs to native VLAN. And native VLAN is 100, so whatever PCs are there in VLAN 100, it will forward to those PCs.
yes, sir. Oh, God.
In which case we use native villain.
Oh my god, multiple time I am explaining same question, brother. You can watch the video again, okay?
Actually,
Actually, you
there is
joined
some
late.
power outage. So yeah,
Yeah,
correct.
so I think so I have explained it 4 to 5 times. Right? Like
Okay, okay, no problem.
any
I'll
scenario we can use when we have, like in a particular VLAN, if we have more PCs, right? So that VLAN can be native VLAN, but by default VLAN 1 is your native VLAN. Okay, sometime we'll use that VLAN as native VLAN where the PCs are not connected, because guys, this is not good for security as well. There is no tag on the trunk link. Let's say there is one attacker and the attacker know the native VLAN is VLAN 100, so they can connect their computer anywhere in VLAN 100, and here is the server in VLAN 100. Now this attacker can access it, right? Later you will understand this attack, don't worry, okay? Then you will understand why we should not configure native VLAN where we have servers or the critical applications, right? This is for the general employees where, let's say, lots of IT peoples are there, sales peoples are there, right? Thousand devices are there, so definitely will not want to perform tagging for all the devices. Otherwise switch is using their CPU, right? And even increasing the length of my data, it is adding some extra information, right? But again, for the security it is not good. So advantage and disadvantage both are there. And what will happen if I will configure native VLAN 100 here and native VLAN 200 here? Can I configure native VLAN 1 on switch 1 and 200 on switch 2?
I think you will get error
No,
of
sir.
native
It's a
VLAN
mismatch.
mismatch.
No.
No, sir. I mean,
I think
Native
for
VLAN 100.
trunking, native VLAN must be same.
So what will happen if I will configure different native VLAN here?
mismatch error would occur.
Yes, you will get mismatch error, because see guys, switch 1 is going to forward untagged traffic for VLAN 100, right? So when switch 2 will receive it without tag on the trunk link, any traffic without tag on the trunk link, it will think this traffic belongs to VLAN 200, because on switch number 2 native VLAN is 200, right? So we'll get error here. Even you can verify it. Let me show you. switch 1. How to verify the native VLAN? How to verify the native VLAN?
In the switch port trunk, sir.
So interface trunk.
So, yes.
Enable so interface trunk. I don't have any trunk link on the switch. Now, if there is no trunk, that means there is no native VLAN, right? So config T interface E0/2, and I am saying switch port mode dynamic desirable. Automatically it will establish the trunking. So interface trunk. Native VLAN is VLAN 1. Command to change the native VLAN is interface E0/2 switch port access, then
Sir, switch port mode trunk native VLAN, sir.
switch port trunk. Switch port
Trunk
trunk
native VLAN and VLAN ID. Native VLAN
VLAN
VLAN ID.
VLAN ID. Right. So 100. So where is the error? I'm not getting any error here. So interface
हाँ
trunk. Hey, please
नहीं
put
यार
yourself on mute, brother.
अरे यार ऑनलाइन कर दे भाई ऑनलाइन अरे यार करवाओ यार ऑनलाइन भेजना है
Okay. Native VLAN is 100. But I am not getting any error. Where is the native VLAN mismatch error?
Sir,
When traffic move from one switch to another switch.
Here native VLAN is 100. Here I am going to set 200. Interface E0/2 switch port trunk native VLAN 200. Yeah, what you are saying? When traffic will goes, let me do one thing. Let me put PC1 in VLAN 100. Interface E0/0 switch port access VLAN 100 and interface. Okay, the PC2 is already in VLAN 20. Fine. Here also interface E0/0 switch port access VLAN 100. Now, can PC1 ping to PC3? Yes or no?
Yes, yes.
How many of you are saying yes? IP 10.1.1/24 and on PC3 IP 10.1.2/24. Let me ping. From PC1 I'm going to ping PC3, both belongs to same VLAN 10.1.1.2. Ping is not working. Tell me the reason. See the switch. I'm not getting any even error. So MAC address table for VLAN 100. Switch is learning MAC address of PC1, but there is no MAC address of PC2. In which VLAN? In VLAN 100. Let me show you switch to MAC address table. Switch to MAC address table. So MAC address table for VLAN 100. No, there is no any MAC address, but in VLAN 200 MAC address table you will find one MAC address, but not there. Even I'm not able to see the MAC address of PC1 in VLAN in the MAC address table of VLAN 200. Right? So VLAN brief. Is VLAN 200 there, guys? Is VLAN 200 there in VLAN database? No.
no.
VLAN 200. Right? Now let me take you to PC1 and again send the traffic. So VLAN brief, now we have VLAN 200 and so MAC address table VLAN 200. Still I'm not able to see the MAC address of PC1. So interface trunk, native VLAN is 200. See, the issue is what? What is the issue?
Yes,
Encapsulation
sir.
protocol.
Yes, sir.
ISL does not support.
Trunk mode is auto.
ISL protocol does not support native
Native
VLAN.
VLAN.
Right. So this is the reason why it is not running MAC address. So interface is 0/2 and switch port trunk encapsulation dot 1q. So interface trunk. Now you can see the encapsulation protocol is dot 1q even on switch 1, and now you started getting message. So interface trunk here also encapsulation protocol is dot 1q, and from PC1 again I am going to send ICMP packet. Now let me take you to switch 2 and show MAC address table, and now you can see the native VLAN mismatch error. Native VLAN mismatch error. Native VLAN mismatch. Native VLAN mismatch discover on Ethernet 0/2 interface. And so MAC address table VLAN 200 not there, in VLAN 100 not there. But switch 2 is, why switch 2 is not learning even the MAC address of PC1? If PC1 is forwarding traffic to 10.2, why switch 2 is not learning the MAC address of PC1? This is the question. Tell
Sir,
me.
switch 2 will receive it on VLAN 200.
Okay.
But switch 1 will be sending it on VLAN 100, right?
Yeah, so
So the packet, I mean, I think the packet will be dropped
where?
on switch 2.
So even
Be,
packet
be,
will drop, then also at least switch 2 should learn the MAC address. Now the first step is learning source MAC address. After that checking the destination MAC.
I think without tagging it is receive, right?
Hmm? Sorry, brother.
Broadcasting is uh, not going on from request PC, sender PC.
Can I show you the capturing?
Sir,
Serial
in
capturing.
switch 2, we not adding PC3 in VLAN 100 or
PC3 is
200.
in VLAN 100. Here is the capturing, and I am going to send again ICMP packet. Is there any ARP message or ICMP packet? No. That means guys, switch 1 is not forwarding it to switch 2. Now tell me why.
because of the mismatch of native VLAN trunk is not coming up.
No. One minute. Switch 1 is learning MAC address of PC1 over here on 0/1 interface, and then it is dropping the traffic. Tell me why switch 1 is dropping the traffic.
Native VLAN on switch 1 and switch 2, both are
Ah,
different.
Because of tagging.
Ethernet slang.
Sir, because of native VLAN mismatch.
Okay, tell me one thing. Sometime interviewer can ask you this question also, like, is there any port available in VLAN 100 on switch 1? Yes or no? Is there any port available in VLAN 100? Answer
Sir,
will be
on
yes or no.
yes,
Yes,
on
sir.
switch 1,
Yes,
right?
on switch 1.
Right.
Yes, sir.
Yes,
ports.
because we have trunk link here. Right? So guys, definitely answer is because of native VLAN mismatch, switch will not forward traffic from the trunk link. And how switch is getting native VLAN mismatch traffic like
Because
information?
switch one,
With the help
because
of
switch one have a native VLAN 100 and two switch में battery VLAN 200. That's
no
why.
question is how switch one is getting this
Because of CDP.
with the help of CDP message.
Yes.
If we'll
Sir,
disable the CDP, then we'll not get this native VLAN mismatch error.
Yes.
So
Yes.
make sure like this is not necessary that every time you will get this message, right? Maybe you are troubleshooting the issue and you are
Then we
not
get
getting
that.
native
Then
VLAN
after that
mismatch.
we get here about keep alive. If I'm not wrong.
No, then you will not get this message, native VLAN mismatch error message. You have to troubleshoot it.
okay, sir. If one end is Cisco and other end is some other Arista or some switch, we won't get any error. We need to figure it out why
Why you will
traffic
not
is
get
not.
any error? You will
This is Cisco Discovery Protocol, right, sir? Other
okay, the
if,
native VLAN mismatch error. Yes, then you have to troubleshoot it by checking the trunk.
trunk. Okay.
Guys, one more thing here. Let's say switch 2 is connected with one another switch here. And I have correct the native VLAN. Here I have set native VLAN 100. Here also native VLAN is 100. Here I have one PC in VLAN 50, right? And in the VLAN database, here we have VLAN 50 and VLAN 100. Here we have VLAN 100 only in the VLAN database. This link is the trunk link. This link is the trunk link. And here we have VLAN 50 and VLAN 100 in the database. And this PC again in VLAN 50. So can this PC and this PC communicate with each other?
Yes.
Here.
Through VLAN 100.
No,
No, sir, no.
no. On 50 they will not communicate.
If yes, then check the packet flow. If no, then tell me where traffic will get dropped. At which device?
Switch 2.
The second switch to it, traffic
Switch
will be
2.
blocked.
Because on switch 2 you can see VLAN 50 is not available in the VLAN database. Right? Means on the trunk link, see this information. In the trunk link, show interface trunk. You can see the VLAN allowed and active in the management domain. Right? Here you will not get VLAN 50. So to process the traffic of one VLAN must be there in the VLAN database. Doesn't matter user is there or not. So that's why we need VTP protocol here to centralize the VLAN information. Okay. So I am going to correct the native VLAN on switch number 2. On switch number 2, I am going to say interface E0/2 switch port trunk native VLAN 100. Native VLAN 100. Done. Now show interface trunk. And now tell me, can PC1 ping to PC3? Again, your answer should be in yes or no.
Yes.
Yes.
What happened? Now tell me the troubleshooting, how you are going to troubleshoot it. How you are going to troubleshoot this issue.
Checking the MAC address table of switch
MAC.
2.
Very good.
IP mismatch.
MAC address table of switch 1. So MAC address table VLAN 100. We have only MAC address of PC 1. On switch 2, so MAC address table VLAN 100. This switch is also learning MAC address of PC1. So IP
Now we will check the trunk.
all. Is it the MAC address of PC1? No. This is not MAC address of PC.
We are checking the switch to, sir.
Yeah, on switch 2 I am saying switch 2 is not learning MAC address of PC1 na. Switch 2 should learn MAC address of PC1 on this interface on this trunk link, yes or no?
That's switch one MAC address. Can we check, sir?
Yes.
Switch 1 MAC address.
Yeah, on VLAN 100. It's learning.
Switch 1 is learning MAC address of PC1, but switch 1 is not learning MAC address of PC3. And switch 2
Because
is
you are
not learning MAC
typing
address of
wrong IP.
wrong
I'll,
IP.
Yes.
Where?
PC1 you're typing to 20.1.2. Sir, there is a 20.1.1.2.
Where?
Yes, it's right. I am wrong. Okay, I wrong.
We will troubleshoot the trunk.
yeah, trunk
Okay.
we will check.
Let me show you. Sir, just tell me the command. What command you want to run? I am going to run. So interface trunk. So see the 0/2 interface is trunk. Mode is dynamic desirable. Encapsulation protocol is .1q with the help of negotiation. Status is trunking and native VLAN is 100. All the VLANs are allowed here and these VLANs are active. In the management domain. So VLAN brief. So you can see PC1 is a part of VLAN 100. Any other command on switch number 1 do you want to run? Now ping is
Sir, it take time for to STP only.
yes 30 seconds.
Okay.
Right, but this way only you will be troubleshooting, right? The trunk, MAC address table, VLAN database, right? On switch number 2 now you can check. So MAC address table VLAN 100. Now you can see this is the MAC address of PC1, right? So PC2 should have MAC address of PC1 on this interface and MAC address of PC3 on this interface, and switch 1 will have MAC address of PC3 on this interface and MAC address of PC1 on this interface. Yes or no? Yes na guys?
Yeah.
Yeah. Okay, so this is all about VLANs and trunking. Now second thing is routing between the VLAN. Routing between the VLAN. For an example, here I have switch 1, some PCs are there, PC1, PC2. I am taking simple topology just to make you understand the concept, and after that you can create the large complicated topology as well. This one, switch 1, switch 2, port number 1, port number 2, port number 3, port number 3, port number 1, port number 2. Okay, then VLAN. So this interface is in VLAN 10, this interface is in VLAN 20, this interface is in VLAN again 10, this interface is in VLAN 20, and this interface is trunk. Right, here IP address is 10.1.1.1, here IP address is 10.1.1.2, here IP address is 20.1.1.1, here IP address is 20.1.1.2. MAC address of PC1 is A, MAC address of PC2 is B, C and D. Switch 1, switch 2. Yes. Okay, so make sure you know that PC1 can communicate with PC3 and PC2 can communicate with PC4, and you know all the step, like how PC is going to generate the traffic from zero, from the ground level, right? How switch is going to process the traffic, how switch is going to build the MAC address table, how switch is going to look up the MAC address table to forward the traffic, how switch is going to perform the tagging, how switch is going to remove the tagging, everything. Now question is how these two different VLAN will communicate. How VLAN 10 and VLAN 20 can communicate.
Inter-VLAN.
Right. So as you know, to forward traffic in different subnet, we need what? Gateway. We need what? Gateway, right? Like from PC number 1, if I am going to ping 20.1.1.1, what PC1 will do? PC1 is going to find the network ID of destination IP address. Network ID of destination IP address is going to be 20.1.1.0. With their on slash value, CIDR value, subnet mask, it will find the network ID. And network ID of PC1 is 10.1.1.0. So both belongs to different subnet. Both are different, right? So now PC1 will look up for the gateway. If gateway is not configured, then you will get error. Error will be what? Gateway is not configured. Right? So ping will not work. Now, here how to add the gateway. So guys, for inter-VLAN routing, this particular thing, like making communication possible between different VLAN, is called inter-VLAN routing. Right? Between the VLAN, inter-VLAN, and within the VLAN, intra-VLAN. Right? So you know the intra-VLAN communication. You know the intra-VLAN communication. Now you are learning inter-VLAN communication. For inter-VLAN communication, we need layer 3 device. What we need? We need layer 3 device. Layer 3 device. It can be a router or it can be layer 3 switch. Right? So if you are going to make communication possible between different VLAN, or you are going to perform inter-VLAN routing with the help of router, then that method is called router on a stick. That method is called router on a stick. And on the multi-layer switch, like layer 3 switch, you can make it possible by creating SVI. SVI stands for
Switch virtual interface.
Switch virtual interface. Okay. So both method we are going to cover one by one. First, let's understand the router on a stick. So guys, with the help of router on a stick, what we can do here, we can add one router. For an example, this is my router. I'm going to connect this router to switch R1. Done. This is, let's say, F0/0 interface of router, and this is port number 4. Now this link, the link which is connected with router, must be configured as trunk, because again this port is going to carry traffic of multiple VLAN 10 and 20. Yes or no?
Yes.
So this interface must be configured as trunk, right? And encapsulation protocol between router and your switch must be same. Now here I have two VLAN. I need two gateway, but on the router we have only one interface, one physical interface. So what we'll do, we'll divide this physical interface of router into two parts. That is called sub interface of router, F0/0.1 and F0/0.2. Done. I am going to configure encapsulation protocol .1q on this interface for which VLAN? For VLAN 10. What? Encapsulation protocol .1q. .1q. And here on this interface, encapsulation protocol .1q for VLAN 20, right? And then IP address. Here for an example, IP address is 10.1.1.254, and here IP address is 20.1.1.254, and we can configure this IP address as a gateway on all the PC belongs to VLAN 10, and this IP address as a gateway on all the PC belongs to VLAN 20.
Sir, interface F0.1 denoted as a VLAN ID.
No, this can be
Then
anything. It can be 100, it can be 500, any value.
okay. So what do you mean by it?
It is by like creating sub interface,
Sub
dividing
interface
one
means
physical interface into
virtually,
multiple.
sub interface means virtual interface we are created.
Not I am creating the virtual interface, just I am dividing the physical interface into multiple virtual interface.
And one interface, if there is exist one physical interface, we create multiple sub interface on a physical interface.
Yes.
Okay.
Clear? Now guys, when PC1 is going to ping to, let's say PC2 VLAN 20, what will happen? Source IP 10.1.1.1, destination IP 20.1.1.1. Let me set it over here. Okay, so if I am going to ping PC2 from PC1, source IP 10.1.1.1, destination IP 20.1.1.1. Yes or no? Yes, everyone? Yes, na?
Yes, sir. Yes.
Source MAC A, destination MAC, it will look up ARP table, right? If entry is not available, it will put it on hold and it will generate ARP request message. In the ARP request message, target IP address will be the gateway IP address, because destination belongs to different subnet. So MAC address will be the MAC address of gateway, means 10.1.1.254, and then source MAC will be A and destination MAC will be what? All F. All F. It will forward to switch. This is the ARP request message. It will forward to switch. Switch will receive it on this interface, which is a part of VLAN 10. Right? Now switch is going to forward one copy from this trunk link and one copy from this trunk link. Yes?
Yes, sir.
When router will receive, router will check destination MAC all F. Destination MAC is all F, and before forwarding on the trunk link, switch will add tag value as well. Means .1q header. Switch will add .1q header as well. Now, when router will receive, router will check destination MAC all F. It will check type field. In the type field, value will be what? Type code of .1q protocol. It will hand over to .1q. .1q protocol is going to identify the VLAN, right? It will see VLAN is 10. VLAN ID is 10. So it will hand over it to this interface F0/0.1. It will hand over to this interface, right? This interface will check ARP message. ARP is target IP address is IP address of F0/0.1. So it will generate ARP reply message. In the reply message, it will send the MAC address, right? When PC1 will receive ARP reply message, it is going to encapsulate the frame. ICMP request message. Again, source MAC A, destination MAC. Now, destination MAC address of router. Let's say here MAC address is, guys, P. MAC address over here is Q for an example. MAC address. Let me change the color as well. Okay. So destination MAC address is going to be P. It will forward to switch. This time switch is going to learn source MAC address. Again it will check destination. Destination is P. It will forward from this link. Router will receive. Router will check destination MAC P. It's my MAC address. And there will be .1q header. It will check the VLAN ID. VLAN ID is 10. It will hand over to 0/0.1. 0/0.1 will check destination IP. Destination IP is 20.1. It will check routing table. In the routing table, route is available, right? 20.1.1.0 is available on which interface? F 0/0.2. So router is going to add new layer 2 header here, where source MAC is going to be Q and destination MAC is going to be what? B. Right? And then it will forward to again switch. Switch will forward to VLAN 20. In the same way, PC1 will ping PC4 also, like this way. Reply will also come like this only. Got it? PC1 and PC2, how will it will communicate? It will communicate like this. Right? So you can imagine like there are two link, one for VLAN 10, one for VLAN 20, right? So it will traffic will go like this and then this. When it will generate reply, like this reply will come. Got it? If VLAN 10 and 20 users are not able to communicate, you are going to check the encapsulation protocol, you are going to check the trunk, you are going to check the MAC address table, right? You are going to check the routing table of router, you are going to check sub interface configurations, and this way you can fix it, to troubleshoot it. Now here if I am adding one more router, sorry, not router, switch. I have switch number 3. This is an interview question. Here we have one user. In VLAN 30. VLAN 30 and IP address of this order is 30.1.1.1. MAC address is, for an example, E. Switch 3. Again the link between switches is trunk. This link is the trunk link. Trunk. Fine. Here on switch number 3 we have VLAN 30 only. On switch number 2 we have VLAN 10 and 20, and on switch number 1 also we have VLAN 10 and 20, right? But on the router we have created one more sub interface, that is F 0/0.3 for an example. F 0/0.3, right? Encapsulation protocol .1q for VLAN 30. .1q and IP address is 30.1.1.254. Question is, can PC1 ping to PC5 30.1?
No sir, that intermediate switch doesn't have VLAN 30.
Okay, now the second question is, if I will ping 30.1.1.1 from PC1, where my traffic will get dropped? On which device?
Trunk port, switch, first, third port.
Switch 1, switch 2, switch 3. Which switch? Or router?
Switch 1.
That would be which one?
Switch
It will be dropped on switch 3.
Switch 1 cannot add VLAN 30 tag on this trunk link.
Yes sir.
Right?
VLAN 30.
Now question is, which packet will get dropped? The request packet or the reply packet, like a packet which is going from PC to router, or the traffic which is coming from router to switch?
It will be dropped on the switch itself. It will not be forwarded to R1.
Will router 1 forward it to router 1? Switch 1 will forward it to router 1 or not?
Sir.
No.
No, it will not.
All are saying no.
Sir, gateway is there, right? So it will drop at a trunk, right? I mean, I think PC might generate and it will
Brother, why
drop a
you are
trunk,
not
right?
taking the packet flow? See, again I am pinging to different subnet, means gateway will be the default gateway, like destination MAC will be the default gateway MAC address, right? Source IP 10.1.1.1, destination IP 30.1.1.1, source MAC A, destination MAC
E. E.
P, P,
E.
not E, brother.
E.
P.
Yeah, I said it's E.
Destination MAC will be P, the MAC address of gateway. This one.
Oh,
Right?
okay.
PC will forward to switch. Switch will receive out this interface, which is a part of VLAN 10, which is part of VLAN 10. Now switch is going to forward it from trunk link or from the port which are member of VLAN 10. So it will forward one copy from here and one copy from here. Definitely switch will forward it to router, brother. Why you are saying no, switch will not forward it to router? Switch don't know anything about the IP address, the 30.1.1.1. Switch will have entry in the MAC address table, that in the MAC address table of switch 1, there will be some entry like in VLAN 10, MAC address is A, port number is 1. Then again VLAN 10, MAC address is P, and port number is 4.
Yes, sir.
So when switch will receive this frame, switch is going to simply update the A MAC address in the table, then it will check destination MAC is P. It will forward it from the port number 4. Will router generate traffic? Yes. Router will generate traffic. Router will forward it to 30.1. So router need what? MAC address of 30.1. Source MAC is going to be MAC address of this interface. Let's say R is the MAC address of F0/0.3 R. So source MAC will be what? R. And destination MAC don't know. So if don't know, then it will generate ARP request message. In the ARP request message, source MAC R, destination MAC all F. It will forward to switch. Now switch is going to discard it. Right? Now switch is going to discard it because VLAN 30 is not active on this trunk link. Okay? Right? So you can say the traffic which is coming from router to switch will get dropped on switch number 1. Okay. This is router on a stick. The another method is SVI by L3 switch. By L3 switch. So now guys, see here, I have two switch. Switch 1, switch 2. Here I have one PC in VLAN 10, one PC in VLAN 20. Here also one PC in VLAN 10, one PC in VLAN 20. And this way only we are connecting devices in real time. Guys, I am getting some noise from somewhere. Please put yourself on mute. Yeah. Switch 1, switch 2. Okay. VLAN 10 and VLAN 20. VLAN 10 and VLAN 20. So these are my layer 2 switch. Now I need one layer 3 switch, multi-layer switch here, right? So let's say this is my multi-layer switch. and I can connect both the layer 2 switch like this, right? D switch 1, distribution layer switch 1, or we can say multi-layer switch 1 MLS. Okay, this port is the trunk port. This port will be trunk port. This port will be also trunk port, right? But again, VLAN 10 and VLAN 20 must be there in the VLAN database of multi-layer switch, right? So here I am going to create VLAN 10, VLAN 20, and then we'll create two virtual interface here, one for VLAN 10 interface VLAN 10, and on this interface you can configure IP address 10.1.1.254/24, then interface VLAN 20 and IP address 20.1.1.254/24, this way. Done. So here IP 10.1.1.1, here IP 20.1.1.1, MAC address A, MAC address B, right? MAC address of VLAN 10 interfaces. See, now in the routing table of this MLS switch will have two route, 10.1.1.0 connected on VLAN 10 interface, right, and 20.1.1.0 connected on VLAN 20 interface. For an example, here MAC address is again P, and here MAC address is Q. Okay, so if I am going to ping 20.1 from 10.1, source IP 10.1.1.1, destination IP 20.1.1.1, source MAC A, destination MAC, gateway MAC address A, and destination MAC is going to be P, right? It will forward to switch, layer 2 switch. Layer 2 switch is going to receive it on this interface. It will forward from the trunk link. MLS will check destination MAC will match. It will check destination IP address. It is 20.1, right? So it is going to change the layer 2 header. Now, whatever devices have capability to change layer 2 information, like whenever traffic will go from one broadcast to another broadcast domain, right, then layer 2 information will be changed. Layer 2 information will be changed. And whatever devices have capability to change layer 2 information will decrement in TTL by 1. Whatever devices are changing layer 2 information will decrease TTL by 1, right? So then it will, MLS will forward it to switch to this PC. This way communication will happen. Is lab required, guys, or you guys can configure it by yourself? Same, this is the only way to configure it. Tell me, should I configure it?
No,
Yes,
no,
sir.
we can configure ourselves.
You can configure, everyone?
Yes, no need.
Sure, there is one query to me. In a switch, there known protocol is run.
On which switch?
Sir, MLS1.
Okay.
There, because we move the data we have by the help of VLAN. Okay, we assign IP.
.1Q protocol is running here on the trunk link.
Okay. Fine.
Okay, so but make sure, guys, you will configure it.
Yes, can I ask one question, please?
Yeah, sure, why not?
You show the inter-VLAN routing on the router.
Okay.
Yeah, and you created from one interface. You created three sub interface.
Correct.
Yeah, and you said you have the MAC address of all three interface. How are we gonna get the MAC address? The router gonna create by itself?
Yeah, router is going to create it.
Okay. And another thing, how many sub interface we can create maximum back in,
Depends on
or is there's
hardware.
a limit, or is there no limit for that?
Depends on the
Okay.
platform of your device, like the memory, CPU, those things, right? But more number of sub interface means less performance, because it is going to store 3 subnet in the routing table, right? So this is not like we can create 1,000 number of sub interface, but definitely performance will get reduced.
Yeah. Thank you.
Sir, I have one question in SVI.
Okay.
When how MLS are defined if we have same IP interface on switch 2 also like a 20.1.1. So how can he decide which packet where the packet flow in on switch 1 or switch 2?
See, when MLS switch will receive the traffic, it will receive traffic at physical layer, then data link layer. Data link layer is going to check what? Destination MAC address. If destination MAC address is MAC address of MLS switch, then only it will accept, or if destination is broadcast, right? If destination MAC is MAC address of MLS switch, then it will check what? It will check tag field, right? VLAN tag value,
Yes, sir.
right? Then it will check destination IP address, and it will compare destination IP address with routing table. And in the routing table, you can see networks are available on the virtual interface, right? So for 10 subnet exit interfaces VLAN 10, for 20 subnet exit interfaces VLAN 20. But for VLAN 10 and 20, traffic will be forwarded from the trunk link only. So to forward the traffic, switch will use MAC address, not IP address, right? It will check the MAC address table, like I need to forward traffic to 20.1.1.1. Let me check the MAC address. Where it will find the MAC address? It will check MAC address table. In the MAC address table, it will find the interface, either this interface 0/0 or 0/1, right? If the entry is not available, then it will perform a non-unicast forwarding. It will forward from both interface. Got it?
Got it. Got it. Got it.
Anything else? Okay.
Sir,
So
can we perform router on a stick if we allocate a dedicated port for every VLAN access port instead of trunk?
yeah, you can use, see here, 3 link for 3 VLAN, right? One will be in VLAN 10, one will be in VLAN 20, one will be in VLAN 30. That is also fine. Both will work.
Thank you.
Now guys, what I told you here, PC1 cannot ping to PC5, right? The reason is this PC and this PC cannot communicate. The reason is VLAN 30 is not available in the VLAN database of switch 1, as well as VLAN 30 is not available in the database of switch 2, VLAN database of switch 2, and VLAN 10 is not available in the VLAN database of switch 3. So VLAN 10 must be here, VLAN 30 and 10 must be here, VLAN 30 and 10 must be here, right? So how to centralize the VLAN, right? Here on switch number 2, you have created 2 VLAN because you have users in these 2 VLAN. But this switch need to forward traffic of VLAN 30 also, maybe more VLAN 40, 50, 60, 100. So we need some solution to centralize the VLAN, like some protocol with the help of that we can automatically centralize the VLAN information, right? Like automatically, if switch 3 is going to share VLAN 30 information to switch 2, and then switch 2 is going to send it to switch 1. That means all the switches have all the VLAN. Now all the devices can communicate. So to centralize the VLAN information, we come up with a protocol called VTP. We come up with a protocol called VTP to avoid these types of issues in the network. Okay, so let's understand the VTP protocol. And in the real time, you will be not using router on a stick most of the time. Like sometime definitely you will be using router on a stick as well, like if in the small organization, but in most of the cases SVI for the inter-VLAN routing, we are using multi-layer switch, VTP. Okay, so guys, VTP stands for VLAN trunking protocol. Again, it is layer 2 protocol, and it sends their message on multicast address, same multicast address 0110 0 CCC and 4 times C. Right, the multicast address of DTP, VTP, CDP all are same. Right, it is used to centralize VLAN database. It is used to centralize VLAN database, and it is Cisco proprietary protocol. We can run it on Cisco devices only, and by default VTP is enable or disable?
Disable, sir.
It is enabled on all the switches. By default it is enabled on all the switches, right? So VTP is an VLAN centralized management protocol, centralized VLAN management protocol, you can say, right? So but by default VTP is enabled, then why here the VLAN is not centralized? Or in this scenario, why the VLAN is not centralized? Because guys, there are some requirement of VTP, right? Before talking about the requirement, let me discuss how VTP is going to work. See, switch 1, switch 2 and switch 3. So what will happen here? If I am going to create one VLAN on switch 1, switch 2 and switch 3. If I am going to create VLAN 10 here, VLAN 10. So what this switch will do, this switch is going to update VLAN database, means it is going to update VLAN.dat file, and after that whenever any change will occur in the VLAN database, switch is going to forward this file VLAN.dat file to their neighbor switch, to switch number 2. It will forward this VLAN.dat file to switch number 2. Now switch number 2 is also going to update their VLAN database, and then it will forward their VLAN.dat file to switch number 3. Right, means switch 2 is also going to create VLAN 10 here. It will create VLAN 10, and then it will advertise VLAN.dat file to switch number 3. And when switch number 3 will receive it, switch 3 is also going to create VLAN 10. This way it is going to advertise VLAN. Now you can see I have created VLAN only and only on switch number 1, but automatically VLAN is created on all the switches, right? But by default you can see VLAN is not propagating. Like here you can test, you can create one VLAN on switch number 1. First of all, I am going to remove all the VLAN from here. Say no VLAN 2 to 100, right? And so VLAN brief. Now guys, see 0/1 and 0/3 is in VLAN 1, but where is 0/0 port? Why I am not able to see 0/0 port? Because 0/0 is a part of VLAN 100 and VLAN 100 is not exist in the VLAN database. That means that VLAN is, that interface is inactive, right? So whenever you will get these types of issue, which command you will use here? If we are not able to find the interface in VLAN database, then which command you will use? So interface is 0/0 switch port, right? This command will give you the information. Here you can see this port is a part of VLAN 100 and the VLAN 100 is inactive. Remember the state, VLAN state, inactive, right? So here I have to configure this interface in VLAN 1, switch port access VLAN 1, or we can say default interface is 0/0, this command, right? And now you can verify. You can see now this port is in VLAN 1, and as if this is in VLAN 1, you can check the VLAN database. Now you can see all the ports are there. Done. And summary command also I can use to know how many VLAN exist on the switch. You can see these are the default 5 VLANs are by default exist on switch, right? And on switch number 2, if VTP is working, then switch 2 is also going to remove all the VLAN, so VLAN brief. But no, here we are able to see all the VLANs. That means maybe VTP is enabled but it's not working right now, right? Let me delete it. No VLAN 2 to 100, I cannot delete VLAN 1, and then interface is 0/0, sorry, default interface is 0/0, so VLAN brief. Done. VTP is not working. So guys, reason is there are some requirement of VTP. Let's understand the requirement. Requirement of VTP. First requirement is, tell me if anyone know.
VTP domain.
Okay. First thing is
Also VTP
trunk.
modes.
First one is trunking. Link between switches must be configured as trunk. Trunking must be enabled between switches. Then only VTP protocol will work. VTP will not work on the access port. Second, VTP domain name. Domain name must be configured. By default, VTP domain name is null. So name must be configured and must be same, right? So on switch you can check here. I can run command show VTP status, right? So you can see the name is VTP domain name is null, right? So name is not configured here. So name must be configured on the switch, and then it should be same also, must be same. Third is
VTP mode.
Sir.
Trunking encapsulation protocol must be same. right? The group of devices in single administrative mode. Then VTP password. Okay, VTP password, but this is optional. If you have configured the password, then password must be same, but this is optional. So these are the requirement of VTP. Let me configure it. Let me take you to switch 1, and trunk is already there. So interface trunk, yes, trunk is already there, you can see.
Sir, BTP server, in BTP, in switches, BTP server mode is by default server, I think.
We'll discuss about the mode, brother, just wait.
Okay.
Command to configure VTP domain name is VTP domain. Let's say for an example I am saying Cisco, right? So now you can see the log message. Changing VTP domain name from null to Cisco. Have changed the name. So VTP status. Here also you can verify. The domain name is Cisco. Now on switch number 2 also I am going to change VTP domain name. VTP domain name, sorry, not name, Cisco. So name is same and link is trunk. Here I got one log message, you can see the VTP domain name already set to Cisco. Can anyone tell me how switch 2 automatically set their domain name to Cisco? Guys, with the help of VTP message. When I change the name on switch number 1, switch 1 has sent one message to switch number 2, and through which switch 2 have updated their domain name. Switch 2 has updated their domain name. Okay, so now name
Sir,
is.
BTP message send a trigger या तो फिर
We'll talk about the messages, modes. Wait, brother. Okay. Wait, understand step by step. Okay, it will be better because there are many advanced concepts also. So to understand everything you have to go from the zero only. Okay, so now my VTP domain name is same and link is trunk. I have not configured the password, so there is no any requirement. Now if I will create any VLAN on switch number 1, that will be automatically created on switch number 2, right? And guys, I think capturing is also there. Here is the capturing. See some VTP message, summary advertisement message, subset advertisement message, summary advertisement, subset advertisement, and join message. These are the message on the link. These are the VTP message. We'll see it. Now on switch number 1 I am going to create one VLAN, right? Let's say VLAN 5, right? Is VLAN created on switch number 1? Do so VLAN brief. VLAN 5 is not there. This is also one interview question. Why VLAN 5 is not there in VLAN database? Am I audible?
Yes, maybe because no ports are assigned.
No, brother.
Because his name, VLAN name not assigned.
Okay, name.
There is some logic, I think. I don't know.
PMNet.
Hello.
This is not a requirement to create the VLAN. Like you have to configure the name. Okay, that is not mandatory.
Maybe the VTP works on client and server mode, sir?
No, not related to VTP. This is the basic concept. Like until and unless you will not exit from this mode, it will not create the VLAN, right? Once I will exit from here, you can see I am in VLAN mode. Once I will exit from here, then it will create VLAN 5. Exit, and now you can check the VLAN 5 is created. And now you can verify it on switch number 2. Do so VLAN brief. You can see VLAN 5 is created on switch number 2. VLAN 5 is created on switch number 2. Right? On switch number 2, I am going to create VLAN 6, and even name you can see the every informations are propagated. VLAN 6 name CCNA and exit. Right, now go to switch 1 and check on switch number 1. So VLAN, you can see VLAN 6. Okay, so now my VTP database is updating, working fine properly. Yes or no?
Yes, sir.
Great. Now there are some modes. One by one, I'm talking about the theory first, at the same time showing you the lab. Types of or modes of VTP. So guys, the first mode is server mode. Now in VTP we have 3 versions: version 1, version 2 and version 3. According to version 1 and version 2, right now I'm talking about version 1 and version 2. So according to version 1 and version 2, VTP has 3 modes. According to version 1 and version 2, VTP has 3 modes. First mode is called server mode. Server mode, which is the by default mode on some platform of switches.
Sir, could you please explain, repeat again the version, sir? I breaking some.
There are 3 versions. Right now I am talking about version 1 and version 2. Later we'll see the version 3 also.
Okay, sir. Okay, sir.
Right. According to version 1 and version 2, we have 3 modes in VTP. First one is server mode, second one is client mode, and third one is transparent mode. Transparent mode. Got it? What is server mode? Let's understand first all the modes one by one. And here let me create one topology also for better clarification. Switch 1, switch 2 and switch 3. On all the switches I have configured VTP domain name Cisco. All the switches I have configured VTP domain name Cisco. Here it's Cisco, here also it's Cisco, and here also it's Cisco. Right? Switch 1. Why sometimes it's happening like automatically the font size is getting lower, decreasing. Switch 1, switch 2 and switch 3. Now on switch number 1 I have created VLAN number 10. Right, so if when I will create VLAN 10 on switch number 1, what will happen? Switch 1 is going to update their VLAN database, and after that it will advertise VLAN.dat file to switch number 2. Switch number 2 is also going to create VLAN 10 in their VLAN database, VLAN 10, and then it will update VLAN database, and then it will share updated information to switch number 3. Switch number 3 is also going to create VLAN 10. Guys, guys, by mistaken, if someone is going to run no VLAN 10 command on switch number 3, no VLAN 10 on switch number 3, what will happen? Switch 3 is
It
going
will
to remove
remove.
VLAN 10 from their database, and then it will share updated information to switch number 2. Switch number 2 is also going to remove VLAN 10 from VLAN database, and then it will send to switch number 1 updated information, and switch 1 is also going to remove VLAN 10 information, VLAN 10 from the database, right? Now VLAN 10 is not there in any switch, like here. Here from the switch 1, if I am going to say no VLAN 5, right, what will happen on switch number 2? You can verify VLAN 5 is removed. So VLAN brief, you can see VLAN 5 is removed, right? So that's why we have multiple modes. According to our requirement, we'll configure the mode. For an example, here on switch number 3, we have general employees, right? Like the fresher engineers are connected through this switch. So these guys can run no VLAN commands. I don't want to allow anyone on switch number 3 to modify the VLAN database. I don't want to allow anyone to modify VLAN database on switch number 3. This can be my requirement, right? These users should not be able to remove VLAN 10 information. Or maybe sometime my requirement can be like, if we are removing any VLAN from the switch, then there should be one switch from that I don't want to remove that VLAN. For an example, on switch number 2, I have lots of servers. I have lots of servers in VLAN 10. Servers in VLAN 10. And outside user, means remote side user or from the internet, are accessing these servers. So if you are going to remove VLAN 10 from switch number 2, the access of this server will not available. No one can access the server, yes or no? So maybe sometime I don't want to participate a switch into VTP domain. I don't want to update VLAN database with the help of VTP on this particular switch, because here we have critical users. So that's why we have modes. Okay, so first mode is server mode. Server mode. In server mode, you are allowed to add, delete and modify the VLAN. We are allowed to add the VLAN, we are allowed to delete the VLAN, we are allowed to modify the VLAN database. Anything we can do in the server mode. This is default mode on some switches. Default mode on some switches, right? And the server mode switch always generate VTP messages, update messages, and it work as a relay agent. Means first it will update their database, VLAN database, and then it will forward the updated information to their neighbor. Okay. And on the server mode, we can only create normal range of VLAN, right? Remember, a standard VLAN and extended VLAN. So standard VLAN only we can create. We cannot create extended VLAN. That's why we have VTP version 3. Version 1 and 2, we cannot create extended VLAN. And it store VLAN database in the VLAN.dat file. Right? So on the server mode, you can delete the VLAN, you can add the VLAN. But on the client mode, the second mode is client mode. Here you are not allowed to add, delete and modify the VLAN. At this mode, you are not allowed to modify, delete or add the VLAN. Then how will create the VLAN on the client mode? You can create VLAN on the server mode, and that will propagate to client mode switch, right? So client mode switch can create, can delete, can modify VLAN from the server mode switch from the VTP message, from the VTP update message, right? It can receive VLAN information from the server mode switch. It also work as relay agent, and here we are not allowed to modify the VLAN database. Now the third mode is transparent mode switch. Transparent mode. Guys, in transparent mode, you are allowed to add, delete and modify the VLAN. Allowed to do these all, but not through VTP messages. Not through VTP messages, right? So on the transparent mode switch, we can manually create the VLAN, we can manually delete the VLAN, right? It will not update their VLAN database through VTP message. Through VTP message. On the transparent mode switch. And it also work as a relay agent, means when transparent mode switch will receive VTP update message, it is going to forward to their neighbor switch, other switch, without updating their own database. On some platform of switches, transparent mode is also default mode, right? And here also you can create normal range of VLAN. Here you can create both normal as well as extended. Both types of VLAN can be created on transparent mode switch. Any doubt? Question should be, Praful, where I should use server mode, when I should use client mode, and when I should use transparent mode. Okay, this is my question. Definitely I will explain it. If you have any other question, please ask. Hello? Hello?
No, sir.
Yes, sir.
Proceed, sir.
No question, sir. Kindly.
It's simple, right? On server mode, we can create, delete, modify the VLAN. On client mode switch, we cannot create, delete, modify the VLAN. On transparent mode, again, we can create, delete and modify the VLAN, but not through the VTP.
VTP message.
On the client mode, again, on the client mode also we can create, delete, modify, but through VTP message, not through CLI or console port. Now, let's take one example. Here, I have 3 switch. Switch 1, switch 2, and switch 3. What I told you guys, here the senior network engineers are there, like the main admins. These are the main admins who know the value of network, who know the value of deleting one VLAN, what impact will happen if they will delete any VLAN, right? They know which VLAN I should delete, which VLAN I should create. They know which VLAN is the server VLAN, which VLAN is the HR VLAN, voice VLAN, data VLAN, right? And here we have the fresher engineers. Fresher. These guys don't know now the importance of deleting a VLAN, right? These guys have, let's say, only 3 months of experience. The new network engineer, new network engineers, right? So these guys don't know what will happen if I will delete the VLAN 10, right? And here I have the main resources, services, servers on switch number 3. This is my scenario. And here we have only one switch. Now you can imagine there are 1000 switches. There are 1000 switches or 500 switches are there. These are the experienced engineers, admin, right? And these are the servers, main resources, servers. Switch 1, switch 2. Like this we can have 1000 number of switches, right? On some switches there are senior network engineers, on some switches like servers are there, and on some switches the fresher engineers are there, and these switches are further connected like this, or maybe connected with distribution layer switch, not matter, right? Let me connect it to distribution layer switch, that will be better, the real time scenario. This is MLS. And then further MLS is connected with one firewall. MLS is connected with one firewall for an example, or one router, any device. And then this firewall is connected with internet. This is my internet. This is my, let's say, firewall. For an example, just I am trying to make the topology bit interesting, that's why I have added the firewall, don't worry. Okay, and on your server, let's say you are hosting one application here, app1, any application, pmnet.com, and outside user from the internet users are accessing these servers every time, right? Like in 1 second you are getting 5000 requests for these servers. Done. And VTP is running. VTP is running on all the switches. Here domain name Cisco, and domain name is Cisco. Anything, right? These links are trunk link. Now you tell me which switch should be in server mode, which switch should be in transparent mode, and which switch should be in client mode.
Switch 1 should be in server mode, switch 2 should be in transparent mode, and switch 3 should be in client.
Very good. Like, as these servers, maybe this server in VLAN 10, this server in VLAN 20, this server in VLAN 30, right? This is in VLAN 10, 20, 30, right? 10, 20, 30, like this, right? So guys, these employees should not be able to modify the VLAN database. So this switch should be in client mode, right? If even the admin are going to delete the VLAN from the VTP, then also VLAN should not be deleted from switch number 2. So this switch should be in transparent mode switch. This switch should be in transparent mode, right? And here these admins are going to manage the entire VLAN database. So this switch should be in server mode. Server mode. Got it? Clear? So where the servers are connected, that switch will be in transparent mode. Means if I want to modify the VLAN database, then manually I have to access it through console, and I can create the VLAN, delete the VLAN. On switch number 1, from switch number 1 we can manage the VLAN database of switch 1 and switch 3. If I will delete any VLAN from switch 1, it will be automatically deleted from switch number 3. right? But we cannot manage the VLAN database of entire switches from this switch. Okay, what should be the mode of MLS switch?
They are in transparent because they turning all the VLANs from all
Yeah, both will
switches.
work here.
Work as yes.
Transparent is also fine and client is also fine. In most of the scenario, transparent mode. Transparent mode. Okay. So now if I am going to create VLAN 10 here on this switch, what will happen? VLAN 10. Switch 1 is going to update their VLAN database, right, in the VLAN.dat file, and then it will share VLAN.dat file to other switches, to MLS switch. MLS switch, transparent mode, it is not going to update their database, but it will forward to other switches. Again, switch number 2, transparent mode, it will not modify their database. If there is any other trunk link, then it will forward from that link, right? When switch 3 will receive it, client mode, again it is going to create VLAN 10, right? So switch number 1 and switch number 3 will create VLAN 10. That's it. On switch number 1 and on switch number 3 we'll have VLAN 10. Okay, and it's very simple. You can connect 3 switches, 4 switches, and then you can change the mode. Like on switch number 2, for an example, I am going to set transparent mode switch or client mode. So VTP mode client, very simple. Now you can see setting device to VTP client mode. Now if I will try to create VLAN, let's say 50 here, what it's saying, VTP VLAN configuration not allowed when device is in client mode. We are not allowed to create the VLAN over here. But if I want to create VLAN 50 on this switch, I can create it on switch 1. Enable config T and VLAN 50. Exit. Right? And now you can verify the VLAN database of switch 2. Do so VLAN brief. You can see VLAN 50 is there. Done. And now if I will configure transparent mode switch, so VTP mode transparent. Transparent mode. Now here we are allowed to create VLAN 60. You can see. Done. Do so VLAN brief. VLAN 60 is there. Will I have VLAN 60 on switch number 1? Will I have VLAN 60 on switch 1? Yes or no? Yes or no? No, guys. No, you will not have VLAN 60 on switch number 1 because transparent mode switch is not going to generate any VTP update message. Right? In the VTP, transparent mode switch is just a relay agent, that's it, nothing more than that. This switch is not going to create any VTP message, even it is not going to open the VTP message, it will receive from one switch, advertise to other switch. So do so VLAN brief. You can see VLAN 60 is not there, right? If I will create VLAN 100, again this VLAN will not created on this switch. You can see 100 is not there. Got it?
Yes, sir.
Now now let's understand the CR number. CR number. What is CR number? Anybody have idea?
Configuration revision number.
No.
Configuration.
That is the full form.
Okay. CR number is sir. VLAN add in a database or remote database.
CR stand for definitely configuration revision number.
Just example of VLAN, if you create VLAN, it will add one CR number. If deleted VLAN, then it will add one CR number. If I am wrong. Yeah.
Good. It is 32 bits value represented in decimal. So you can find the range. It is used to, what we can say, it is used to, not like this, we can say it will increment in CR number by 1 whenever any change will occur in the VLAN database, right? If we are going to create the VLAN, it will increase CR number by 1. If you will delete the VLAN, then also it will increase CR number by 1, right? Not like this, like if I will delete, then CR number will decrease by 1. Whenever database will change, whenever change will occur in the database, it will be incremented by 1. It is used to check the VLAN database is updated or not. So whenever a switch is going to receive VTP message, first it will check the CR number. Right? If let's say the CR number on the switch is 10, and it is receiving a VTP message where CR number is also 10, then switch is not going to open that. That means this is not updated information. But if CR number in the message is 11, that means my CR number is 10 and the CR number is in message is 11. That means this is the updated information. So switch is going to update their VTP database with the help of this message. Switch is going to update their database on the basis of this message. Fine. It is used to check updated information, right? Then always keep in mind, by default CR number is 0 on all the switches. By default CR number is 0. Done. So here you can see on switch number 1, again I am going to say no VLAN 2 to 100, and do so VTP version, what happened, sorry, status. So CR number is 12. How to make it 0? VTP domain name. Domain I can say CCNP. And now you can check the VTP status. CR number is 0. Right? Now if I will create a VLAN here, VLAN 10, and on switch number 2 also. On switch number 2, let me show you switch number 2. Do so VTP status. Name is Cisco and the CR number is 0. Okay, this switch is in transparent mode. So on transparent mode, CR number will be always 0 because it is not going to update their database with the help of VTP. Here I am going to set client mode, VTP mode client, and do so VTP status. CR number is 0. Right. Now I am going to get VLAN 10 here. VLAN 10. So CR number will be what? 1. Incremented by 1. On switch number 2 also, switch 2 will receive VTP message. It will check CR number. CR number is 1. But why switch 2 have not updated their database, guys? Tell me. Everything is in front of you. Domain name. Here domain name is CCNP. Here domain name is Cisco. So domain name is mismatching, right? So VTP domain name must be same, CCNP, right? Now so VTP status. Now you can see CR number over here is also 1 and the domain name is CCNP. It have also created the VLAN. Do so VLAN brief. Done. VLAN 10. If I will remove VLAN 10 from here, no VLAN 10, CR number will become 2 here, right? And in the VLAN database, do so VLAN brief will not have VLAN 10. On switch number 2 also, do so VTP status, CR number 2 and do so VLAN brief, VLAN 10 is removed. Okay, so this way CR number is working. By default, CR number is 0. Switch 1, switch 2 and switch 3. CR number is 0, 0, 0 on all the switch.
So can we do domain CR value 0 after any some time?
You have to change the domain name.
Okay, so that's why we need domain name change.
CR number 0, CR number 0, CR number 0. 1, 2, 3. Right. So like whenever now change will occur in the VLAN database, CR number will be incremented by 1. Okay. Hope it is clear. Once I will create VLAN 10 here, CR number will become 1 here, right? And then it will send update message, BTP update message. Switch 2 will check CR number is 1. That means this is updated information. Switch 2 is going to update their database according to this message. If the CR number is 0 or below 0, like let's say configure CR number is 5 and it is receiving message with CR number 3, it will not update their database with that VTP message. Okay, so they can, interviewer can ask you this type of question. Okay, so CR number is used to check that I am updated in the network or not. Whenever we'll add, remove or modify the VLAN, CR number will be incremented by 1. Even if you will change the name of VLAN, it will increment in CR by 1. Now to understand this in better way, we have to understand the messages in VTP. Right, so next topic is types of messages in VTP. Guys, first message is summary advertisement. Second message is subset advertisement. Third message is subset request. Fourth message is join message. So we have these 4 types of messages in VTP. Summary advertisement is an periodic message. Periodically, switch is sending after every 3 seconds. Periodic after every 300 seconds. 300 seconds. Or it will be trigger also whenever change will occur. right? Like if I am creating the VLAN, then switch will send trigger. Okay, whenever any change will occur in the VLAN database, then switch will send trigger. So summary advertisement is an trigger and periodic, both messages. Content, what will be the information inside the summary advertisement message? So this message is going to carry VTP domain name. It is going to carry CR number. It is going to carry VTP version information. It is going to carry MD5 digest value, right? So these informations will be there in the summary advertisement message, but there is no VLAN information you can see. Yes or no? So if I have created the VLAN on the switch, switch will send summary advertisement message which will carry these all information. And if the CR number will be higher, like if switch is receiving a summary advertisement and with higher CR number, that means the VLAN updated VLAN informations are coming. That means updated VLAN informations are coming. So this message is going to identify that my VLAN database is updated or not. And one more information will be there, that is total number of subset advertisement. How many subset advertisements are coming? How many subset advertisements are coming? Okay. So if the CR number is higher, then switch will wait for subset advertisement, because subset advertisement is going to carry the VLAN information, the actual VLAN information. And if after receiving the summary advertisement, if switch is not going to receive subset advertisement, then switch will send what? Subset request message, because switch know that I have not updated database. I have not the updated database. I need updated database. So switch is expecting subset advertisement. If switch will not receive subset advertisement, then it will send request message, subset request message. And in the response of subset request, switch will send summary advertisement. Okay. So and summary advertisement is a trigger message. Trigger means whenever change will occur, then switch will send this message. It is used to share the actual VLAN information, right? So it will contain what it will carry? Actual VLAN information. Right? And in two cases, switch will send summary subset advertisement. One, whenever change will occur in the VLAN database, and in the response of subset request, if switch will send subset request. So in two cases, switch will send subset advertisement message. Hope it is clear. Clear, guys? All these three messages. Is it clear? All these three messages are clear to all?
Yes.
Now this is your homework. Fourth message, that is join message. So tomorrow I will ask you what is the use of join message in the VTP. Okay. And that's all for today.